Greetings, math friends. We are continuing our calculus journey. We are applying the definition of derivative to determine what a derivative is given a function. So we are finding f prime of x, given that f of x is some function. In this particular case, we have x squared minus 5x. To fill in my numerator here, I'm going to have to make a couple of side calculations. F of x is known, it goes here, but we also need to know f of x plus h. So we're going to do that as a separate calculation and then plug it into the numerator. So everywhere that I have an x, I'm plugging in x plus h. So this x and this x are both replaced by the x plus h. This is going to be a double distribution. And this is a single distribution. There are no like terms here for us to gather, so this is going to go into my numerator, and then we're going to subtract this from it because this is f of x. All right, that numerator expands quite a lot. This negative here is going to distribute into the parentheses, so we want to do that to avoid sign errors, and then we are going to simplify what we can. Once we have that plugged in here, we can notice that this x squared and this x squared have opposite signs, so they cancel each other out. The negative 5x here is an opposite side of the 5x over here, so they are canceling out here. And then notice that everything that we have left in the numerator has an h component to it, which will cancel with this h here as a fraction reduction. So I lose an h here, an h here, an h here, and an h here. So this gives us that f prime of x is equal to the limit as h approaches 0 of 2x plus h minus 5 over 1. And we can also look at this as just 2x plus h minus 5 because the fraction over 1 is just that numerator. As h goes to 0, we see that this is simply 2x minus 5. And that is our derivative. That is f prime of x, given that f of x was x squared minus 5. The next function that we are going to determine the derivative of by definition is the square root of x. Determining what f of x plus h is fairly straightforward here. We just take the function and substitute in the x plus h. So substituting this into the numerator and this into the numerator, this is where we land. So now we need to do some algebraic work here to determine the limit as h approaches 0 for this function, which will be our f prime of x. The algebraic process that we're going to do here is one that you've probably seen done when this type of structure is in the denominator, but it's in the numerator this time, and we are going to try to eliminate it because it eliminates the complication of having h in the denominator, because we can't allow h to actually reach 0, because that would be a division by 0, and that is not allowed in this algebra. We are going to multiply the numerator and denominator by the algebraic conjugate of the structure in the numerator. So we take the thing that we have, but we switch the sign in the middle, and we have to multiply that in the numerator and denominator because this is equivalent to multiplying by 1, so we keep the same magnitude of valuation. So this is double distribution, and this is a single distribution. As we do our distributions, I'm actually not going to write out the distribution of this because I know the next step is I want to cancel this h here, so I just leave it as a factor to be distributed. Once I simplify this numerator, that's going to cancel out. Observe that x minus x is 0, so the numerator is just h. I have a common factor of h in the numerator and denominator, so these are going to cancel. This gives me just a 1 in the numerator here. And then this, which was my algebraic conjugate, is my new denominator. And then we're going to let h go to 0, which just gives me a square root here. So I have 2 square roots here. So the final determination that I have of the derivative of the square root of x is 1 over 2 times the square root of x. Hopefully you find some mathematics in your part of the world to enjoy. Try a couple of these problems at the end of the video and check yourself as the solutions appear. Cheerful calculations.